The issue with plastics is we produce over 300 million tons every year. Globally, less than 9% is being recycled because a lot of this material is considered unrecyclable today. We have a new chemical process that breaks plastics down into chemical building blocks, and then we build high-performance plastics that have the same quality as materials directly derived from fossil fuel. All of this packaging, which gets thrown away right after somebody buys and starts using it, all of this, we're working on building to be able to use up more of all the polyethylene waste. To actually solve this problem, we have to move our solution out into the real world. And this is actually very hard to do.
The budget is pretty much done.
Oh, okay, cool. Jeannie's my best friend. She's my co-founder. She's godmother to my son. She was my maid of honor. She and I are, at this point, family.
100% of all the budget line items.
Oh, they haven't? Good, excellent.
In high school, I met Miranda. We quickly became best friends. We were co-presidents of the high school environmental club. We were both from first-generation Chinese immigrant families. We're both very hardworking, and we like to take responsibility to do something that is important for the greater world.
This is one of the main reactors. In just a couple of months now, I think this whole skate is going to be filled up with the reactors and instrumentation and automation.
We have worked with professors, academics who spent more than 40 years looking for methods to break down plastics. I felt this sheer magnitude of this issue. We're making dicarboxylic acids.
The plastic waste is introduced into the reactor right here. So, we've done this in our lab, but scaling up into this industrial environment is a different type of challenge.
This has never been done ever before, and it's very, very critical that we focus on this.
By 2019, we had no clear validation that all these theoretical things were going to be achievable. We basically had to make something identical to what is made from fossil fuels with a starting material that's beyond our control and doing it with enough sustainability and enough cost competitiveness so that it's going to be even a compelling product. And we were turned down by everybody. They were telling us, this is not identical, you have too much contamination. We don't see the easy path here to drop in this process that you have into our existing systems. And we were very close to having to shut down the organization. We have been through some really difficult times. So now when people really talk about, you guys are probably the reason you're still on the path, it's absolutely true. At that critical moment, I became a Rolex laureate, and this was a really big deal for us. We were able to bring in proper analytical equipment, which allowed us to make our reactions better. By 2021-22, we were able to produce beautiful pellets that had the right properties.
But I think what's really important is the ability to scale up so that it's not just a scientific idea anymore and it becomes a real-world solution.
We're putting on the last pieces here, and this is where the products will come out from the system.
These are really important checks to ensure that everything throughout the skid is consistent and working properly.
The largest milestone on this whole journey will be bringing online the Ether, this demonstration plant. Once this is installed, and we finish our water checks, we're going to actually put plastic in and begin the reaction. I hope everything goes well. These pellets are made from polyethylene waste, which is everyday packaging, bags, pallet wrap. Yeah, okay, that's fine. incredible given what it came from. Old plastic trash that had no other purpose.
From the initial QC lab results, we're able to see that this plant is working.
This is a really exciting milestone for us to see that this product coming out at industrial scale is reflecting what we have been able to achieve at the lab scale.
This is really, really awesome.
We take the first product that we make and then we purify it and start building back up into useful materials with our partner Huafeng. Now we look into the future where I envision hundreds of commercial facilities. We're projecting by 2030 to be able to use as much as 175,000 tons of plastic waste and reduce up to 800,000 tons of CO2 on an annual basis. If we can turn the tap off on fossil fuel consumption, that will make a really sizable impact on this entire global plastics industry. Sometimes we have to choose to take the harder path.